So in yesterday's class, we are discussing some of the string handling functions. So I said I'll be giving some more things. strncpy. strncpy. Okay. The use of this one is like to copy only leftmost n characters from the source. This is to copy only the leftmost n characters. N characters like this. As an example, if you take character S1 of 10, character S2 of 10, then if you say scanf percentage S1, let us suppose I have entered here welcome. You have entered welcome, then if you say strncpy, strncpy, S2 comma S1 comma 3. strn S2 comma S1. So it will take from S1. How many characters? 3 characters. That means what is the, if I print the value of S2 now, then what is the output we get here? 3 characters. So if I remove this string, what will happen? It will copy complete string. So if I mention the number of characters here, it will take only that many characters. Clear with this function now?
Yes, sir.
Right? So, similar way, we are having strncat. strncat. So this is also for concatenating. Use it to concatenate with only the leftmost n characters. As an example, take the character S1 of 10, character S2 of 10. So let's say scanf percentage S1. I have entered something here. Hello.
Yes, sir.
Scanf percentage S2. Let us suppose I have entered here URL. Then if I say strncpat, S1 comma S2 comma 3, or let me say 4. S1 comma S2 comma 4 means what will happen now? What is the output?
It will copy hell world.
Hello, URL. So from the second one, it will take only 4 characters. That's the meaning. Not from first one.
Okay.
Not from first one. Okay, first will be same. From the second string, it will take only 4 characters. Okay. Getting slips, Rishwan?
Kind of, sir.
strncpy. Compare I. Simple, same thing. Not case sensitive. Not case sensitive. As an example, to compare strings, use it to compare the strings, but not case sensitive. But not case sensitive. Example, so take character S1, of 10, characteristic of 10. Then if you say I some int, let me take int n, then you can say n equal to strn, sorry, strcp. Before that we have to read the values. Scanf percentage s s1. Let us suppose I have entered here hello. Scanf percentage is s2. I have entered here hello, like this. Okay, both are hello only, but their case sensitivity they are different. strcmp I s1 comma s2. Then what is the value of n here? So value of n is 0. Then what we can say? Printf s1 is equal to percentages is equal to percentage. Clear? Not case sensitive.
Yes, sir.
Okay.
Yes,
So
sir.
these are the sum of the functions. Then today we will be discussing about structures, unions, and concepts. The remaining part. Okay. Very simple one. So structures and unions are very easy topic. What is the use of arrays?
Use of array, sir.
What is the use of arrays?
Use it.
Hmm? To collect the elements of similar data type, right? You can collect in arrays only similar data type. But my requirement
Yes.
is I want to collect different data type. In that case, we go for structures and unions.
Okay.
Okay. So
Okay.
these are used. These are user-defined data types. These are user-defined data types which are used to collect the elements of different data types. Different data. So creating a structure. Let us go with the structure first. How to create a structure is, for example, if I just have to use a keyword struct and the structure name.
Yes, sir.
Struct and structure name. So for employee, what details we can collect? Collect the related elements. If you say related, then it will be very much good. Use it to collect the related elements. So like employee, for employee, what are the related things we collect? INT. Employee number,
Employee name.
character, e-name, then float,
Salary.
salary. Right? So all these
Yes.
elements are of what? A different type. So a structure is what? It's a collection of elements of different data types. So it's a collection of related elements. Should be related to one thing. Then in order to, or we can select, we can access the elements of the structure with a structure variable using dot operator. Using dot operator. Okay, like this. As an example, first we have to create a structure variable. Struct employee A. Then A is a variable of what? Struct employee. So here we have to say what here? A is a variable of
Struct employee.
struct employee. Okay. Then by using E only we can access A dot ENY equal to something 111. A dot strcpy. strcpy. E dot ename. Subname. So directly we cannot assign. We cannot say E dot
Yes.
ename equal to Raj directly. I said no, yesterday we cannot directly use equal to operator for strings. Then E dot salary equal to some salary. Clear with this point? Up here?
Yes, sir.
Then how to create a union is, how to create a union is same thing. Union, same syntax. Instead of struct, we have to say union. Instead of struct, we have to say what here? Union. Then create the union variable. Then by using union, we can access same thing. E dot env equal to 111 str cpy e dot ename some name e dot salary some salary. Okay. So then when we are having union and structure, then what is the difference between union and structure? So they are mainly related to memory. So refer diagram, structure wise union dot. So let us understand the difference between structure and union. When you create a structure like this, when you create a structure and if you say struct employee A, then how the memory gets allocated here is, so for let us consider 32 bit. So first it will allocate 2 bytes for employee number.
Yes, sir.
So first it will allocate 2 bytes for your employee number. Then next for employee name 10 bytes. Okay. Then for salary again 4 bytes.
Yes, sir.
Like this. So first 2 bytes is for employee number. Then next 4 bytes is for, sorry, next 10 bytes is for employee name. Then next 4 bytes is for your salary. So all different memory locations. This one is
Yes,
for
sir.
a.envo. And this memory is for e.ename. And this memory is for a.cell. Clear how the memory gets allocated in the case of structure? So all different memory locations. But when you go for union, so when you go for union, you have to express with the diagram only. When you go for union and if you create a union variable, so in this union, which variable is taking the maximum size? Which variable is taking the maximum size? Employee name, right? 10 characters.
Yes, sir.
Employee name is taking 10 characters. So it will allocate memory for 10. It will allocate memory for 10 characters. Then first 2 bytes it will use it for employee number. Then again first to last it will use it for employee name. And next 4 bytes this is used for salary. So all the things are at one place only.
Yes, sir.
Compress it, compresses and stores. So generally we won't use union for general purpose applications. We use unions for system programming. We use unions for what? System programming. If I store the data like this and if I try to print it, we'll get some other machine format when you go for unions. So unions are only for gaming applications or system programming, not for common purpose. So all the things will get compressed at one place. Clear with the difference diagrammatically? The difference between structure
Yes.
and union, right?
Yes.
Okay. Let us write one example program. Write a program to create a structure item with the fields item number, item name, rate, quantity, and price. Rate, quantity, and price. Calculate net price. Sorry, calculate price, display, item number, item name, price. Okay. So let us write this code. Very simple one.
Yes, sir.
Refer program, item structure dot java. Hash include stdio.h main function. You can create a structure. You can create structure outside of main or inside main. If I create structure outside of main, we can even use it outside of functions. Let me create outside of main. Struct item, struct item, then int item number, character item name of some 10, then float, price, float, rate, then price, integer quantity, integer quantity. Then once you create a structure, then we can create the variables here. How to create structure variable? Struct item, some I. So I is a variable of type struct item. Then now you can give the message printf, enter item number, name, rate, and quantity. Okay. Scanf, percentage d, percentage f, percentage f, percentage t, and I dot INO and I dot item number. We have to refer with I only. These variables I cannot refer directly. We have to refer with variable of struct item only. So that's it. And I dot item number. Only if you understand this point, your structures are complete. Okay. Then I dot I name. Sorry, item name. I dot item name. Then and I dot rate. Come and I dot quantity. Clear?
Yes, sir.
Right? That's it. Only refer with structure variable. That's it. Only that is the difference between ordinary program and this. Now your complete struct item I contains what here?
I contains everything almost.
Right. You are all
Item.
the values of item number, name, rate, price, and quantity also. So we have to calculate price now. I dot price. Don't say directly price. I dot price equal to I dot rate into I dot quantity. I dot rate into I dot quantity. Then once you do this one, I'll call a separate function display. To this display, I'll pass I variable. So when I pass I, all the data will be sent to as an argument. Where complete item data will be sent. That is the use of creating structures. Now you got the meaning? We need not
Yes,
send
sir.
separately. Item number, item name,
Yes.
rate, quantity, price. Just pass I. So automatically it contains what? All the item details. Then write the display method. So this display method is taking what type of argument? Struct item. Right? Clear?
Yes, sir.
What is the argument I pass? It's of what type? Struct item. So I'm saying struct item. Then I can say here display means what? Printf item number equal to %t slash n. Same thing again. I dot item number. Same. Anywhere I have to refer with I dot. Item name equal to % slash n. I dot item name. Clear with the program now?
Yes, sir.
Right? Compile and run. It will ask for item number, name, all those things. I'm saying 111. Name, I'm saying mouse. Rate some 300. Quantity some 10. It will print item number 111. Name is mouse and the price is 3. Clear? Same program, but we have written with structures. The main thing is this one. We can pass structure variable which contains all the values of your item variables. One variable contains multiple values. And all these values are what? Same type or different type?
Yes.
So we can collect different type of elements. Arrays can hold only similar type of elements, whereas a structure can hold different type of elements. A structure can contain different type of elements. So,
Yes, sir.
one more point. We are having one more small thing. Type def means type definition. Struct item. So I'm creating my own name and alias name for struct item. So wherever you are having struct item, you can replace what it now? Item. Shortcuts. Clear?
Okay.
Type def, simple shortcut. So
Yes.
whenever I want to refer struct item, now I can refer with item now only. Simple example, one more, like if I say type def float f, wherever float is there, you can refer with what? F. Shortcut, alias names. These are like alias names. Clear, Rishwan? Type def.
Yes, sir.
So, got the meaning of concept of structures? Let us go for the next one, that is pointers. Very important. Pointers. So let me go with an example. When I declare a variable int n equal to 10, int n equal to 10. So what will happen? Let me go like this. With the diagram I can explain very easily. So whenever you declare a variable int n equal to 10, what will happen? It will allocate memory for you, right? It will allocate memory whose name is n and the value inside this memory is 10. Let us suppose the address of this n variable is 100. Let us suppose the address of this n variable is 100. Then we are having one operator called as AND operator. AND operator used to give the address of a variable. What is the use of AND operator? Used to give the address of a variable. Now, I am saying now int p equal to AND n. int p equal to what? AND n. So when you say AND n contains what? Address of n. What is that address of n? 100. That 100 I want to store it into a variable. Then we have to declare that variable as a pointer. Star. We have to declare a variable as what? Star p. Star p equal to AND n. That means now if I say printf %u, now if I say p, what's the output we get here? 100. Because p contains address of n. What is the address of n? Okay. So what is a pointer? A pointer is a variable which contains address of some other variable. Which contains address of
Yes.
some other variable. Okay. What is the use of pointers? Like, let me take it. We are having one more operator, star operator, which we call it as indirection operator. Which we call it as indirection operator. The use of this one is used to access the value of the variable, where pointer is pointing. Use it to access the value of variable where pointer is pointing. Means if I say here int y equal to star p, int y equal to star p, star p. So p is pointing to
Yes.
what? 100 address. What is the value present in this address? Where p is pointing to which variable? N. P is pointing to n. So what is the value present in that address? 10. So when I say y equal to star p, means if I print the value of y, then the output will be what here? 10. What is the output? 10. Clear?
Yes. Yes, sir.
So only two important operators here. And means it will take the address of it. Star means takes the value where it is pointing. So p is pointing to n. P is pointing to n. So similarly, whenever I say star p, you remember n. Blindly you replace star p with n. That's it. That's the way you need to, if you remember, then pointers will become very much easy. Okay. So how to
Yes.
remember? Replace star p with n. Replace star p with n. Then if I say y equal to n, you can easily answer 10. Now if I say y equal to star p, you feel something confusion. What is that? So that is the reason I have given a point. Replace star p with n blindly. Then these things will become very much easy. Now, let me take one more. If I say now star p equal to star p plus 10. Now if I say printf n equal to percentage t, the value of n. Then what is the value of n here? What is the value of n will be?
So, value
Hmm?
in star p proportion 20.
20. Very good. So n will become what here? 20. So it will replace this 10 value with what? Whenever you say star p means it will go to the address of n. What is the value of that n? 10. It will pick up the 10. 10 plus 10, 20. Where you are storing again back into same address. So the value will be replaced here with 10. Clear now?
Yes, sir.
Then what is the use of using pointers? I can even do all these things with a variable n also. Then why I should go with address? Why? Because when I play with addresses, the performance of your program will be more fast. So you know my name. You know my name. Then I'll
Yes.
ask you to come to my home. What you do?
I'll
You have to
ask for
find my address.
address.
You have to find out my address. So it will take some time for you. So once you find out my address, then you have to come. If I give my address to you directly, you can easily come now.
Yes, sir.
Same concept here. So if I play with variables, then it will be slow program. The program will be functioning slow. If I play with pointers, the program is more fast. Okay, because directly you are going to the address and picking up the values. So burden to the compiler will be reduced when I make use of pointers in the program. Clear? Why we have to use pointers in the programs? Only for
Yes, sir.
performance. Okay. So we can define a pointer like a pointer is a variable which contains the address of another variable. Which contains what? The address of another variable. Let us see the programs on this. etr1.c. int n equal to 10, y and star b. The same thing what I have given in diagram, I am writing a program here. Now we are
Yes.
saying p equal to and n. Now p contains what? Address of n. So if I say printf percentage p is stored at address percentage u, because for addresses we have to use percentage u slash n comma p. So what is output we get? 10 is stored at address so and so. See, it will say 10 is stored at address 2686788. Okay, which address it stores we don't know. Okay, so it will say 10 is stored at address 2686788. Some address. How the output will come? 10 is stored at address 26867, some number, whatever it is. Then we'll say now y equal to star p. Then if I say now printf y equal to percentage t, the value of y, then what is the value of y now? 10. Value of y will become 10. Right? 10. Star p means replaced with 10. 10. Now if I say star p equal to star p plus 10, now if I print the value of n now, what's the value of n now? 20. Right?
Yes.
The value of n will become 20. Okay, n equal to 20. Clear with this program? The thing what we discussed,
Yes.
I am showing practically to you. Okay.
Yes.
Now we need to discuss pointers in 3 places. Like we have to see how pointers are used with the arrays, pointers and arrays, pointers and functions, pointers and structures. Okay. So we have to three cases. So first we'll go with pointers and arrays. Pointers and arrays. So refer the diagram, pointers and arrays.
Yes.
Let us suppose we are having an array with values 10, 20, 30, 40, 50. Let us suppose. Then what will happen? It will allocate memory for you, right? Where we can
Yes.
store 5 values. All these elements are connected to array n. Now let us suppose first the the indexes will be what here? Not suppose 0, 1,
1,
2,
2,
3. Okay. Let us suppose now the addresses are, let us suppose 100. Then if I consider 32 bit, 1 or 2, right? 2 bytes each. Clear? 2 bytes each element. Now what are the values inside this? Already I have given in assignment 10, 20, 30, 40 and 50. Right? Now
yes.
what I want to do is I want to find the sum of all these elements. I want to find the sum of array elements. So what we do, I'll take a variable sum equal to 0 and I'll take one more star. Now I'll say I want to do this program using pointers now. Now we'll say p equal to n. P equal to n means what? What is the value of p now? According to our diagram. Don't say and n. You should not say and in here. You have to say p equal to n only. Why? Because array name contains starting address. Do you remember when I discussed arrays? What I said? Okay. The starting address of the array is called as base address. Array is called as base address. And the base address is stored in array name. So in our example, what is array name? N. So n contains starting address. What is the starting address? 100. So now what is the value of pin of 100? Clear up here? Clear? Rishwan?
Yes, sir.
N contains 100. Array name contains starting address. So when I say p equal to n means now p is pointing to this 100 location. P is pointing to 100 location. Now, say like this. For I equal to 0, I less than 5, I plus this. Now say sum equal to sum plus star p. Sum equal to sum plus star p. Now p is pointing to what? 100, right? P is pointing to 100. So when I say star p, what is the value at 100 address?
Star 800 it is 10.
10. So it will take 10 and adds to sum. Then how to go to next location is just by saying p plus plus. So when you say p plus plus, don't think that it will go to 101. It will jump to 2 bytes. So p plus plus means not value. Address will be incremented. So since it is integer, 2 bytes will get incremented automatically. So when you say p plus plus, now the value of p will become 102. Then again the loop repeats. Again say sum equal to sum plus star p. What's the value at 102? What is the value
20.
at 102? 20. So 20 will be added to previous sum 10. Now the sum will become 30. Then again p plus plus. Now it will go to 104. Then again it will take star 104 means 30. 30 will be added to previous sum. Like that it continues. Clear?
Yes.
This p plus plus.
Yes.
So these are the two important points. P equal to n, p plus. So increments by 2 bytes depends on operating system. So if it is 32 bit, 2 bytes, 64 bit, 4 bytes. Okay? Clear? Rishwan?
Yes.
How to
Yes.
manage this? Then once the loop is
Yes.
over, you can print the value of sum.
Yes.
So we have done the same program in arrays also. Then what's the difference? Performance.
Oh,
The difference performance. Let me even make a note. When pointers are used, pointers are used to increase the performance of application. So let us understand this concept using complete program. int n array, I variable, star p, and initial sum equal to 0. Then accept values into array. Enter 5 values. So your array is ready with values. Now say p equal to n. That is the starting address of the array we are storing into pointer. Starting address of array is stored in pointer. Is stored in pointer. Now take the loop for I equal to 0, I less than 5, I plus plus. Then you can say sum equal to sum plus, instead of taking n of I, we have to say star p. Why we have to go with star p means performance wise pointers are more fast. Then go to the next location. If increments by 2 bucks depends on operating system. Means next element value. Next element value of p plus plus means it will take the next element value. Like that it repeats for 5 times. And once the loop is over, it's a printf sum equal to percentage t, the value of c. Compile and run. So if I give 5 values like 10, 20, 30, 40, 50, then sum is what here? Clear? Vishwan?
Yes, sir.
Let us go for the next one. Pointers and functions. One more, very important. Pointers and functions. Here we are writing two important definitions. Call by value and call by reference. Call by value and call by reference. Then call by value is like calling a function by passing values to the arguments of the function. You are calling a function by passing what? Values. When you pass values to the arguments of function, we call it as call by value. Call by reference is calling a function by passing addresses to the arguments of the function. So when you pass addresses to the arguments of function, we call it as call by reference. When you pass only values, we call it as call by reference. Let us understand what is the advantage of going for call by reference over call by value. So for that one, let me write a program. Refer program swap 1 dot swap 1 dot swapping means what? Interchange.
Yes, sir.
Okay. Let us write that code first, then understand what is the problem with call by value, then we'll solve it the same with call by reference. Swap with call by value. Main. I'm taking two variables int n1 comma n2. Accept these two numbers, printf. Enter two numbers, scanf, %t, and n1 comma and n2. Then now say printf before swap n1 equal to %t, n2 equal to %t slash n, the value of n1 comma n2. Then I'm calling the function swap where I pass n1 n2. Now after that I'm calling the function swap where I pass n1 n2. Then after that again we'll say after swap n1 equal to %t, n2 equal to %t slash n, the value of n1 comma n2. Now write the swap function. How many arguments it is taking? 2 arguments.
Yes.
Then what is the, do you remember the formula for swap? Identity t equal to n1, n1 equal to n2, n2 equal to t. Do you have idea of this? Do you have an idea of this?
Yes, sir.
Technique.
Sir.
Right. Swap logic. If I say n1 equal to 10, n2 equal to 20, then I want to make n1 as 20 and n2 as 10, right? So how to do that? T equal to n1 means t will become 10. T will become 10.
Yes.
Then n1 equal to n2 means n1 will become 20. The value of n2 is given to n1. So n1 will become 20.
Yes.
Then if I say n2 equal to t means n2 will become now 10. Okay. So first we have to store n1 value into one temporary variable, then change the value of n1 to n2, then take the temporary value to n2. This is the logic of swapping. Clear, Rishman?
Yes, sir.
Okay. Same thing I am doing here. Same logic. What are the values you pass? I am doing here. Okay. What is the output we get here? Enter 2 numbers. Enter 2 numbers. So I'll say here 10, 20. Then it will give the message before swap n1 equal to 10, n2 equal to 20. Then after swap, what is the output for you? What is the value of n1 and n2? After swap?
20 10.
20, 10. Repeat that.
20 and 10, sir.
20 and 10. See here. If I say 10, 20, the output is before swap n1 equal to 10, n2 equal to 20. After swap also n1 is 10 and n2 is 20. So is the program working?
No, sir.
No. So why the problem is occurring? Local variable. Local variable. So when you see here n1, n2, in this one, the value of n1 is 10. n2 is 20, right? In the, and this n1, n2 memory locations, when I accept the value of n1 is 10, 20. So this n1, n2 I can use only within main function, right? Local variable. Local variable. Clear?
Yes.
I can use this n1, n2 only within the function. When I say swap n1, n2, what will happen? This n1 value will come to n1, means the value of n1 will be 10, n2 will be 20, right? Then I am saying t equal to identity, t equal to n1, then n1 equal to n2 means this n1 will become 20, n2 equal to t means this n2 will become 10, and I can use this memory only within this function. I can use that memory only within this function. Then when I go back to the main program, when I try to take n1, n2, what are the values of n1, n2 here? 10, 20 only. So 10, 20 here. So I cannot solve this problem with call by value. Using functions, I cannot solve this problem with call by value. Then the solution is what? Call by reference. The solution is what here for this? Call by reference. Let us write. Same program. Call by reference. So pass the addresses here. And n1 and n2. So when I pass n1 into addresses, then there should be some pointer to store it. Star p, star q. Star p, star q means p contains address of n1, q contains address of n2. Right? When I pass addresses, it is call by reference. So p contains address of n1, q contains address of n2. Now say identity t equal to star p. Star P means what? The value of N1. Star P means the value of N1. So the value of N1 is stored in T. Then star P equal to star Q. Star Q is pointing to N2. So N2 value will go to N1. Means which address? This address. It will go to main method only because we are passing the value to addresses are changed, not values. So since P contains address of N1, when I say star Q equal to star P, the value present in N2 will go to address of P. Where address of P? N1. So it will go to this. Star Q equal to T means the value of T, that is 10, will go to address of Q where it is pointing. So it will become T. So by using function, I can go to some other function and I can violate the local variable. Now you'll get your correct output. 20. Clear?
Yes.
Reverse this. 2010. Now we got the correct output 20. Clear, Ishwant, about this?
Yes, sir.
Right?
Yes.
So revise this properly once again. You draw the diagrams. You draw the memory locations here, pass that addresses here. Then you will understand properly about this stuff. Okay. So that's about
Yes.
call by value and call by reference. And this is about your calls, pointers and functions. Pointers and functions. Okay. So
Yes, sir.
we are left out with one more thing in pointers, that is pointers and structures. That I'll discuss tomorrow. Then we'll go with
Yes.
even files concept tomorrow.
Yes,
Files also will be discussed. Okay.
Yeah.
Any questions, Vishwan?
No, sir. I'll ask you on later.
Right. Just to go through this and you can ask.
Yes.
Okay. Thank you very much. Thank you.
Thank you.